Qualitative analysis. Test for anion. In this video, you will learn about the procedure in conducting the test for anion and the results that you should expect to get for the 5 anions in the syllabus. What are anions? They are negatively charged ions. Anions are formed when non-metals gain electrons. Examples of anions include the chloride ion, Cl-, bromide ion, Br-, oxide ion, O2-, sulfide ion, S2-. These are monoatomic ions. They are formed when an atom of a non-metal gains electrons and become negatively charged. Other examples of anions include the hydroxide ion, OH-, the carbonate ions, CO3, 2-, sulfate ion, SO4, 2-, nitrate ion, NO3-. These are the polyatomic anions. These are groups of negative ions formed when 2 or more non-metal atoms covalently bonded together. There are 5 anions in the syllabus that you will be required to know in specific testing. They are the carbonates, chloride, iodide, sulfate, and nitrate. Unlike the cations, there is no fixed steps in the testing of anions. The basis for anion tests is dependent on various concepts, such as the reaction of acids to test for the carbonates, the solubility of salts to test for the presence of chloride, iodide, and sulfate, and redox reaction for the testing of nitrate ions. You may want to make reference to your notes on some of these concepts: the reaction of acids and the solubility of salts. For redox, it will be covered in Sec 4. We start by looking at the test for the carbonate ions. Copper 2 carbonate is placed in a test tube. In the other test tube, we have a sample of lime water. Hydrochloric acid is added to the test tube containing the carbonate ion. You notice that effervescence is observed. The gas evolved is bubbled into a test tube of lime water. The lime water turns chalky. The gas evolved. Carbon dioxide is given off. When the gas is bubbled into lime water, it turns lime water chalky. It is also said that a white precipitate is formed. The identity of the white precipitate is calcium carbonate. Next, we'll look at the test for chloride ions. A solution containing chloride ion is placed in a test tube. Dilute nitric acid is first added to the test tube of solution. This is followed by aqueous silver nitrate. It is observed that a white precipitate is formed. The white precipitate is silver chloride. Based on the solubility table, we have learned that all chlorides are soluble, except for lead-2 chloride and silver chloride, and this appears as a white precipitate. Next, we'll look at the test for iodide ion. Since chlorine and iodine are both in group 7 of the periodic table, each with 7 valence electrons, we would expect the two elements to have similar chemical properties. Hence, the test for iodide ion will be similar to that of chloride. A solution containing iodide ion is placed in a test tube. Dilute nitric acid is added to this test tube. This is followed by aqueous silver nitrate. We notice that a pale yellow precipitate is formed. The identity of the yellow precipitate is silver iodide. Next, we move on to the test for sulfate ions. A solution containing sulfate ion is placed in a test tube. Dilute nitric acid is added to this solution. This is followed by aqueous barium nitrate. A white precipitate is formed. The identity of the white precipitate is barium sulfate. Based on the solubility table, all sulfates are soluble, except for calcium, lead-2, and barium. There is an alternative test for the sulfate ion. Instead of using barium nitrate, we can use aqueous barium chloride. For consistency, since chloride ion is present, the acid that is used would now be dilute hydrochloric acid. Finally, we move on to the last anion, the nitrate ion. A solution containing nitrate is placed in a test tube. Aqueous sodium hydroxide is added to the sample of nitrate solution. This is followed by placing a piece of aluminum foil into the mixture. Aluminum foil is a reducing agent and it will generate a redox reaction with nitrate, changing it to ammonia gas. We will need to warm the mixture gently and to test for the gas evolved using a moist red litmus paper. Effervescence is observed and a pungent gas is evolved. This shows a redox reaction has occurred between the aluminum and the nitrate ion. Upon testing the gas with a piece of moist red litmus paper, the gas turns the moist red litmus paper blue, indicating the presence of ammonia gas evolved. We have come to the end of the lesson video series. Thank you for watching the video. If you have any comments or suggestions, feel free to leave them in the chemistry website. Thank you.